Hello students, let us solve a problem from NEET UG Paper 2021. Here is the problem. The problem says that a spring is stretched by 5 cm by a force of 10 Newton. Now you have to find out the time period of oscillations when a mass of 2 kg is suspended by it. Here there are 4 options. You have to find out the correct one. So let us solve the problem. First let us think that there is a spring which has a length x at its equilibrium or normal condition. Now if a force, external force F is applied to stretch the spring, and suppose the spring is stretched by a certain length delta x, then due to this stretching there will be a force arising in the spring which will act opposite to the applied force, and it will try to restore the length of the spring which was earlier at the normal condition. So that's why this force is called restoring force, and the restoring force can be written as F is equal to K delta x, where F is the external force at equilibrium situation and K delta x is the restoring force that arises in the spring, and K is the spring constant, delta x is the change in the length of the spring. And in the given problem, F is 10 Newton and delta x is 5 centimeter. If we write that, then see, we get this equation. But here look, the spring constant K is not given for the spring. So if we solve for K, we get the spring constant as 200 Newton per meter. Now when there is a simple harmonic oscillation sets up in spring, the angular frequency of the oscillation of the spring can be obtained by omega is equal to under root k by m. Once we get angular frequency, we can find out the time period as 2 pi by omega. If we put the value of omega, we get t is equal to 2 pi under root m by k, and this m is here given as 2 kg in this given problem, and k we have already found out 200 Newton per meter. If we plug the values, then we get upon calculation 0.628 second as the time period of oscillations of the spring, and hence fourth option will be the correct answer for this problem. Thank you.